Today's is on location. I am still Captain Berger, and I'm excited to step you guys through this class. All right, so we're going to talk about an example of why land nav is important, and that's going to be focusing on the 23rd of March, 2003. If you guys can think back to this date, what some events that might have been happening, a big one that probably stands out is the invasion of Iraq. So most of you probably do not know who this guy is, but you definitely know who this is. On the left, that's Jessica Lynch. She was the first female POW, first female prisoner of war taken from the United States. On the right is her company commander, Captain Troy King. So Captain King was the convoy commander for the ill-fated convoy that Jessica Lynch was on that was ambushed in En-Nasiriyah in Iraq on their way into Baghdad. So their convoy was part of a larger movement up into Baghdad, and they were supposed to navigate sort of in situ with these other convoys going, but they were still in charge of their own navigation and their own route. So Captain King had two tools with him. He had a commercial GPS, and he had a 1 in 100,000 map with no routes marked. Now, if you guys recall from Miltopo 1, a 1 in 100,000 map is not what we use for ground operations at all. We use 1 in 50,000, 1 in 25,000. 1 in 100,000 is for large-scale planning and air operations. That is not what he should have been using in the situation because it made it very difficult for him to do any kind of terrain association or orientation to his surroundings. And a commercial GPS is unreliable, satellite signal may not be useful, and maps in it may not be updated per the current standard of his surroundings. So they ended up coming into En-Nasiriyah, and they took a wrong turn unbeknownst to Captain King and were ultimately ambushed in the town. So this is important because he was unable to use his surroundings to realize that he was in the wrong place and identify that they had not successfully turned where they needed to in order to, one, remain on a safely cleared route, and two, continue on into Baghdad. So huge consequences that could have been mitigated by some very simple understandings of land navigation and the skills and tools associated with it. So we're going to step through some of those skills and tools today so that you guys don't make the same mistake as Captain King going forward in your career. So things we're going to cover are map orientation, inspection, resection, and intersection. Again, purpose of the class, we're giving you the ability to determine the coordinates of your position or a distant position by performing those things. So this is going to give you those skills to be able to figure out those positions. And some motivated photos there. I myself am a communication strategy and operations officer, so I always like a good photo. All right, so map orientation. This is the first one we're going to cover. Orientation is the determination of the relative position of something or someone, especially yourself. And there's two parts that we're going to cover. Orientation to grid and magnetic north, and orientation via inspection. So the first one is orientation via grid and magnetic north. And this one is where you use your compass and your map to orient your position. So first thing you do is you lay out your map in front of you with all those eastings facing up, and then you lay out your compass fully and place that straight edge along the eastings. You then note the direction of that north-seeking arrow on your compass, and then you can turn yourself and the whole thing, the map, the compass, and yourself, so that that arrow is then facing north. You can see here that arrow is now facing north as well. We've turned the map to align to that direction. However, if you guys think about it, we know that grid north and magnetic north are not equivalent. Here in Quantico, we have that GM angle, that 11 degrees west, that we should probably account for. So what you want to do is slightly adjust your compass so that you're able, if you look here, to account for that GM angle. So what you want to do is offset the compass to reflect the GM angle relationship, that 11 degrees. All right, that's going to give you an accurate understanding of where your compass is pointing compared to the surroundings and your map. However, what you guys are probably going to rely on most here at the basic school and in general land navigation is orientation by inspection. If you look at this 1940s era graphic here, we have a Marine looking at his map and comparing it to his surroundings. The church in front of him matches the church on his map, as do the hill to his right. Right, this is the skill that you're probably going to use when you're walking along a road and you come to an intersection, you're trying to figure out where you are. All right, you do this all the time. Think about when you go to a mall and you use one of those arrows that says you are here, right? You're going to verify that position by looking and saying, hey, I can see Macy's in front of me and J.C. Penney over to my left. That means that I am where I think I am, right? That's something that we do every day. Orientation via inspection is the exact same thing. Here's a quick hands-on application. This is the firehouse that's across from the gas station and mini PX on MCB1. If you guys come in the north gate on this side of base, right? You guys have probably driven past it a lot. We want to figure out where that is on the map, right? So we're looking at our map and we can identify the firehouse, right? We know that's the firehouse and we can find the firehouse on our map, but now we want to make sure that we know where we're standing on this map compared to what we're looking at in our surroundings. So firehouse is in front of us, so we're going to turn our map so the firehouse on our map is also in front of us. We're then able to verify all of these features on the map off of where we're standing. So we can see MCB2 going off to the left in real life. We can also see that on the map. We can see MCB1/4 going off to the right, MCB2 on the left, MCB1/4 on the right, MCB1/4 on the right, going down there both in the map and in real life, and we can see the firehouse in front of us. By that logic, we know that we are standing where that red box is on that map. We are there at that intersection of hot patch, MCB2, and MCB1/4. All right, so resection. Resection is locating your unknown position by sighting in on one or more features on your map. All right, you need to remember that resection finds your position. A handy mnemonic device for this is re is me. Re is me. All right, or re is for reverse or back azimuth. Just remember, this skill that you're about to learn for resection finds your unknown position. All right, so here's the steps on how this is going to work. Orient the map, plot known points on the map, shoot an azimuth from your unknown position to both known positions, convert that magnetic azimuth to a grid azimuth, then you convert that grid azimuth to a back, draw that back azimuth from the known points using your protractor on your map, and then where the lines cross is your position. That's a lot of word vomit. Let's see this in action so you guys can get a good understanding. Here's a map, and if you look at that yellow box, you know that you are somewhere in that yellow box, but you don't know any more precisely than that. And you're trying to find your position, right? So you know you're somewhere in that box. From where you're standing, you see two hills, all right? That one up at the top of the map and that one on the bottom. You can see them from your position and you can identify them on your map as well, all right? So what you're gonna do is you're gonna take out your compass and shoot an azimuth to both of those hills from your position. So for that top hill, where you're standing, you shoot an azimuth, is magnetic. You then subtract 11 to convert that to grid, getting 44 grid. But we need to take the back azimuth of that to get 224, because then what we're going to do is we're going to go up to that hill on our map and we're going to draw that back azimuth from the hill out to the area that we think we're in, right? We're going to draw that back azimuth out. So now we know that we fall somewhere on this line. We don't know precisely where yet, but we know it's somewhere on this line is where we're standing. So to be able to pinpoint it even more, now we're going to do the same thing with the other hill. So we got out our compass, we shot an azimuth to that other lower hill, and it was 130 degrees magnetic. Subtracting 11, we get 119 grid. Adding 180 to get 299 as our back azimuth. We then draw that 299 azimuth from that hill out to where we are. We now see where those two lines are converging, where they intersect, and we know that that's where we are. So we can then use our protractor and plot that grid, and we know exactly where we are, and we have a grid coordinate for our position. All right, so that's resection. All right, you found your position using 2 points that you could see in real life and on your map. All right, there's also something called 1-point resection. But to do this, your unknown location must be on a linear feature. You must be standing on a road, an easily identifiable road, a very significant stream, something that is a linear feature that is easily identifiable. That is the only way that you can use 1-point resection. All right, this is how it's going to work. You know that you're standing somewhere on this river. You're standing on the edge of it. You're practically in it, but you don't know exactly where. You don't have a grid, right? So from where you're standing, you can see that hill up on the right side, and you're able to shoot an azimuth to it. And you're looking through your compass, and you get an azimuth of 50 degrees magnetic. Subtracting 11, you get a grid azimuth of 39 degrees. All right, converting that to a back azimuth, you get 219 degrees grid. You're going to draw that grid azimuth right from that hill out across the river, and then you know where that hill, that azimuth from the hill, intersects with the river is where your location is. All right, so then you're able to use your protractor, pull that grid, and figure out exactly where you are. That is 1-point resection. Again, you must be on a linear feature for this to work. All right, next we have intersection. All right, intersection. By determining the location of an unknown point, you do this by sighting in on the unknown point from one or more known positions. So intersection is when you're trying to find out the grid of someone else's position. You know your position, but you're trying to find theirs. Like this is maybe when you're in your defensive position, right, out in the tree line, and you see enemy in front of you. You're able to shoot something to them to get their grid and maybe call a polar mission in for call for fire. That's the kind of context that you would use this in. All right, Comstrat photos, motivate. All right, intersection. These are the steps for intersection. First, you orient your map, plot known points on your map, shoot an azimuth from both positions, convert the magnetic azimuth to a grid azimuth, draw the grid azimuth from the known points using your protractor, and then where the lines cross, you have an intersection of two lines, and you can now determine the grid using your protractor. Again, lots of words. Let's step through this visually. Here's a map. You see an enemy down there in that bottom half. You can see them and you have a rough idea of where they are, but you want a grid because you want to call for fire on their position. All right? So you have an LPOP up at that hill on the left-hand side and another LPOP on that hill on the right-hand side. Both LPOPs can see the enemy in that river valley. All right, so LPOP number 1, they get out their compass and shoot an azimuth to that visual enemy that they can see, and they get 150 degrees magnetic. We then convert that to a grid azimuth of 139, and we draw that grid azimuth from the hill out to the general area where we think the enemy is. We now know the enemy falls somewhere on this line, right? Then we radio over to our other LPOP, and we'd have them look at the enemy through their compass as well, and they say, hey, from our position, through our compass, the enemy bears 220 degrees magnetic. We then convert that to grid as well, getting 209 grid, and on our map, we draw that line out all the way from that hill till it intersects with that original azimuth from hill 1, and we figure out that, hey, where those two lines intersect, that's the enemy's position. We are then able to use our protractor and pull a grid for those guys. You can also do one-point intersection, but just like with one-point resection, one-point intersection must also use a linear feature. Very similar concept. So again, here we have the enemy. They're right there on that creek bed. Maybe they're taking cover in the stream. We're not sure, but you can see them, so clearly it's not that effective, but they're in that stream, and you know, hey, I want to be able to quickly get a grid for that position. All right, so from your LPOP up on that hill, you were able to pull that 150 degree magnetic azimuth, right? Subtract 11, converting that to a grid of 139, draw that 139 azimuth, and you were then able to use your protractor and pull a grid for where that line intersects the stream, because you know that's where the enemy is because they are on that known linear feature. All right, now we're going to step through a couple examples, and you guys are going to pause the video once I'm done explaining and work through these on your own. You are the platoon commander for Red Platoon, Delta Company, 3rd Light Armored Reconnaissance Battalion. As the lead element for your battalion landing team, your mission is to screen forward to phase line Alpha in order to observe and identify enemy positions along the I-95 corridor. Your platoon reaching phase line Alpha will trigger the next stage of the attack. As you are moving, you realize your GPS is malfunctioning, showing the same grid from 30 minutes ago. The battalion landing team is expecting you to report when you are in position and to hear that the way is clear to continue. All right, you move on to higher ground for a better vantage point, and you see the Marine Museum in Tango Hotel 9568 on a magnetic azimuth of 083 degrees. Should look something like that. And then you see a tower in Tango Hotel 9467 on a magnetic azimuth of 153 degrees. Should look like that. And you need to determine the 8-digit grid coordinate to your location. So go ahead and pause the video and figure that out. All right, welcome back. This was an exercise in resection, so you guys should have been trying to find your own unknown position by utilizing that resection technique. So if we look at our maps, we can see that Marine Corps Museum, where that green dot just appeared, right? That is the first thing that we saw, and we had that initial grid magnetic azimuth that we pulled from our position. So, excuse me, we had that 083 magnetic azimuth. We subtracted 11 to get that 072 grid azimuth. All right, we then added 180 to get a 252 back azimuth. All right, 252 back azimuth. We then draw that back azimuth from the Marine Corps Museum out across the map. We know that our position is somewhere on this azimuth, but we need another one to intersect it to verify exactly where. That other one's going to come from that tower down there on the bottom, right? You can see that down there, that other green dot. So we take that tower, and we had that 153-degree magnetic azimuth from our position. Convert that into grid to get 142, take the back azimuth of that to get 322, draw that out across our map. Where those two lines intersect, that is now our position. So pretty much, you see that hill that those lines intersected on. If you guys fell anywhere on that hill, that's probably a pretty good job for your first attempt at a significant resection exercise. All right, so good job if you fell anywhere on that hill. For mine, the grid that I got was Tango Hotel 93886824. But again, if you fell anywhere on that hill, excellent job. You clearly understand, hey, that's roughly where we're supposed to be. Good job there. You are celebrating your successful resection. All right, moving on. Suddenly, you've now pushed beyond phase line alpha and are continuing to screen the battalion landing team to the east as they conduct their attack. You set up with one section in the vicinity of what appears to be a school and another section in the vicinity of an old rectory. Suddenly, you get an alarmed call from your section at the school. An enemy mortar platoon has uncovered from a hidden position several kilometers to your rear and is orienting toward the landing team's attack. All right, so Alpha section, they're in the rectory. They can see that enemy on a magnetic azimuth of 331 degrees. All right, something like that. And then Bravo section, they're in the wide water school. They can see the enemy on a magnetic azimuth of 022 degrees. All right, so using that information, determine the 8-digit grid coordinate for the enemy location. Go ahead and pause and do that now. All right, hopefully you were able to take as much time as you needed to do that. So now let's step through this intersection, right? We've done our resection. This is now intersection because we are finding the enemy's unknown position, someone else's unknown position. So here, looking at our map, we have that rectory down there on that right side. You see that green box appearing for it? Right, from the rectory, we had that 331 magnetic azimuth. We convert that into grid, and we draw that grid azimuth out across our map, right? And then we had our Bravo section. They were down in Wide Water School. You see that other green box has just appeared, right? And from Wide Water School, we had a 022 magnetic azimuth. We subtracted an 11 for that GM angle, and we got a 11 grid azimuth, all right? And we draw that also out across the map. So again, you can see those two intersect somewhere on that hill. If you guys fell anywhere on that hill, that's a pretty good go at it for early on map work. So good job if you were on that hill. All right, using your protractor, you can then pull a grid for that intersection. The one I got was Tango Hotel 93706412. All right, so go ahead. If you need to do this problem again, you want to keep working on it, that's fine. But this was an exercise in intersection. All right, intersection. There you are, successfully firing on the enemy. All right, so in summary, you've learned map orientation, inspection, resection, and intersection today. Those are all great skills. If you need to go back and do those practice ones again, please do. Intersection and resection are not necessarily things that you're going to be doing in your land nav events, but they are things that you guys are going to do in your field exercises. All right, these are going to make you money when you're in the defense or on the offense and trying to call for fire on an enemy position or figure out where you are. All right, so why is this important? Thinking back to that commercial GPS that Captain King had, those things can easily fail you. All right, we don't want to be reliant solely on that technology that has risk associated with it, right? We want to be able to fall back on those reliable techniques, utilizing your compass, your map, your protractor to be able to figure out where you are and fix and help yourself and your Marines in a pinch, right? Again, going back to the 23rd of March in 2003, Captain King's errors and consequences for the 507th Maintenance Company were dire. 7 soldiers became prisoners of war. There were 11 KIA, all right? Think about the loss of life that was associated with something as simple as a land navigation error. Yes, we can talk a lot about his convoy's response to the complex ambush they found themselves in, but at the end of the day, it started with his inability to navigate his convoy appropriately. Right? He wasn't able to conduct that inspection and realize where he was and get his company and his convoy back on track. All right. I like to end this class with this quote from MCDP 1 Leaders must have a strong sense of the great responsibility of their office, as the resources they will expend in war are human lives. Obviously, we're not all going to be O302s, but we may all be in positions where we are forced to make decisions that could ultimately have an effect on a Marine's life, right? And think about all the planning considerations that go into something as simple as a convoy. All right, I've had to use land nav as part of a convoy when I was the only officer present in Syria. That was a wild time for me as a Comstar officer, but it's something that happened to me, right? You guys want to understand these very foundational principles, because in a time of stress and extreme measures, people are going to turn to you as a Marine officer and be like, hey, we know you guys know how to do this. Can you help us out? And you want to be able to have those tools at your disposal so that you know what to do. Again, we're not all going to be grunts, but we are all Marines, and this is something that is expected of us as officers. All right, if you guys have any questions, please email me. Again, I'm Captain Berger. You guys will hear my voice again for a couple more platforms, and I look forward to seeing you guys out in the tree line. Have a great day.